Okay, last time we learned that any base raised to the 0 power is equal to 1. So we learned the 0 power property, which says any base raised to the 0 power is equal to 1, no matter what that base is. Any base raised to the 0 power is equal to 1. All right, so we learned that if we have 25 raised to the 0 power, that's going to equal 1. So 25 to the 0 power is equal to 1. 2000 raised to the 0 power is 1. X to the 0 power is 1. 2x, all of that was raised to the 0 power, so that whole thing is 1. Even cupcake to the 0 power is equal to 1. But we do have to be careful. We talked about this last time because you have to be paying really close attention to what exactly is being raised to the 0 power. So in this example, 2 times x to the 0, 2 is not being raised to the 0 power. It's just 2 times x to the 0 power. So really that's going to become 2 times 1, because x to the 0 power is 1. Now 2 times 1 is just 2. Make sure you don't add those. Some people were adding those. That wasn't an addition sign. Don't do that. Okay? All right, we have 3 times AB raised to the 0 power. Now once again, any base to the 0 power is equal to 1, so that whole thing becomes 1, and that is 3 times 1, which is 3. And then in this last example, we have 4x to the 0 power plus 5y to the 0 power. We have to go through and specify, make sure we're careful, what is exactly raised to the 0 power. So looking at this, 4x to the 0 power, our x to the 0 power is the only thing being raised to the 0 power right here, not the 4. That's 4 times x to the 0 power. And so x to the 0 power becomes 1, so really this is just 4 times 1. Do not add 4 plus 1. It's 4 times 1, which is 4. And then we have plus 5y to the 0 power. That whole thing is being raised to the 0 power, so the whole thing becomes 1. So 4 plus 1 is equal to 5. So that's what we learned last time. What we're learning today is the product property. So we're going to go ahead and build on our properties of exponents that we've learned so far. This is the second property we've learned, and it's the product property of exponents. So what the product property of exponents says, if you multiply the same exact base, then you will add the exponents. Once again, if you multiply the exact same base, then you will add the exponents. Now I'm going to highlight real quick. This part is the rule. It's just written in like the mathematical way we'll look at this. So notice we have base a raised to the n power times by base a to the n power, and we're multiplying the same base. So what we're going to do is we're going to pull this thing we're going to take this thing that we have split apart, and we're going to pull it into 1. So if we're multiplying the same base, so we were multiplying a to the n times a to the n, we're going to add our exponents. So that's equal to a to the n plus n. So notice here, I just added my exponents. Now don't make the mistake of thinking when you multiply the same base, you multiply the exponents. That feels like so natural. You want to do that, but that's not true. When you multiply the same base, you'll add the exponents, and I'm going to tell you why. I'm going to show you why in just a second. But let's first do this first example here. So we have a to the second power times a to the third power. We have the same base, and we're multiplying it, so we're going to add the exponents. So we can combine this into 1 by adding the exponents. So 2 plus 3. And that's equal to a to the 5th power. And that will be our final answer. Now, why? Why does this work? So I'm going to show you. A squared is the same thing as a times a. And a cubed is the same thing as a times a times a. We're multiplying all those things. So how many a's do we have? 1, 2, 3, 4, and 5 a's. So that's why it's equal to a to the 5th. So that's why the rule works, but you have to remember, when you multiply the same base, you add the exponents, but you have to have the same base. Let's look at another. All right, so example number 2, we're going to simplify this. X to the 5th times times x to the 3rd times x squared. We have the same base, yes, it's x, and we're multiplying the same base, so we're going to add the exponents. So this is simply x to the 5th plus 3 plus 2. So we really have x to the 10th. And that's the most simplified answer. Now, in example number 3, we're simplifying a squared times x cubed. Those are not the same base. We can't simplify it. So this is the simplified form. You can't combine those using properties of exponents. They're not the same base. A and x are not the same base. All right, simplifying this example. This one throws people off, but it shouldn't. We just have to be really careful. And this is where some of the most common mistakes come in. So we have x squared times x. Let's simplify it. Do we have the same base? Yes, x, and we're multiplying it. So we add our exponents. Well, we have x squared, and then we have an x, but what is my exponent on x? It's not 0, it's 1. So it goes without being said. If there's not an exponent up there, it goes without being said that there's a 1 up there. All right, so we have x to the 2 plus 3, because when you multiply, 2 plus 1, because when you multiply the same base, you're going to add the exponent, so we're going to get x to the third. Now that makes sense, right? If we have x squared, I'm just saying this is why it makes sense. If we have x squared times x, that would be the same thing as having an x and an x for x squared, and then times x, and that leaves us with 3 x's. But just keep that in mind, okay? Just keep that in mind. So it makes sense. But just be really careful, because guys, the most common mistake is right there. People forget that there's a 1 there, and they don't count it. Let's do this one. 2a to the 5th times 3a to the 4th. The first thing you need to understand is that 2a to the 5th is not connected. It's just multiplication. So really this is the same thing as 2 times a to the 5th. And once again, the 3a to the 4th, it's not connected. That's the same thing as 3 times a to the 4th. And now I went off and showed you this example before. This is a little aside, is 3 times 2 the same thing as 2 times 3? Well, 3 times 2 is equal to 6, and 2 times 3 is equal to 6. So no matter what the order is, if we reorder these, if you reorder 3 and 2 to be 2 and 3, no matter what way we order this, when we're multiplying, you're going to get the same answer. So you can reorder multiplication in any order. So what I'm going to do here is I'm going to reorder this. I'm going to reorder this. So I'm going to rewrite my numbers by each other. So we have 2 times 3, and then we have times a to the 5th. I'm going to put my bases that are alike by each other, and then we have a to the 4th. And now we'll just go through piece by piece and simplify this. So really, these are the exact same thing, though, keep in mind, but they're in a different order. And now we'll just simplify it. 2 times 3. Now, the property of exponent rule does not work for numbers. You have to just multiply your numbers. So 2 times 3 is 6. Those were not the same base. We don't add their exponents. And you don't add the numbers, guys. You do not add the numbers. The rule is, if you have the same exact base, then you will add the exponents. So this one, when you have numbers, you're just going to multiply them. 2 times 3 is 6. And then now let's focus on this part. We have base a to the 5th times base a to the 4th. And when you multiply the same base, you'll add the exponents. So we have a to the 5 plus 4, which is 9. So 6a to the 9th, that's my final answer. All right, let's do another one. 3x times 3x to the 4th. Now, once again, the 3 is not connected to the x, and the 3 is not connected to the x to the 4th. So we can reorder this in any order, and let's go ahead and do that. So really, this is 3 times 3. I'm just reordering this times x to the 4th. All right, so same thing, different order, and then I can go through and simplify it. I'm going to focus on 3 times 3. That is 9. Now I'm going to focus on x times x to the 4th. Don't make that mistake that people make. Don't forget there's secretly a 1 in that exponent. So when you multiply the same base, you add the exponent. So that's going to be x to the 5th. So 9x to the 5th, that would be our final answer. All right, now when we see something like this, students tend to make a lot of mistakes with something like this, and I can guarantee for the most part that there is going to be one of these on the test, so we have to be really careful. So the rule says if you have the same exact base, then you will combine them by adding, and you're multiplying them, I should say, I'm sorry, and you're multiplying the same base, you can add the exponents. Now that didn't change the base, that did not change the base. The base stays the same. So what students tend to do with something like this, 2 to the 2nd times 2 to the 100. They'll double dip, I call it. They like to double dip. So what they'll do, and this is incorrect, so what they'll do is they'll do 2 times 2, which is 4, and then they'll add the exponents, 2 plus 100, which is 102. That would be incorrect. You changed the base. That is not how the rule goes. The rule goes, if you have the exact same base and you're multiplying the same base, then you're going to add the exponents. The base stays the same. So this answer, the correct answer, this was not the correct answer. The correct answer would have been 2, the base stays the same, and then you add the exponents. So that would have been 102. So this would be correct. So please don't make that error. Don't double dip. All right, so do problems 1 through 5 on the worksheet. 1 through 5 on the worksheet. All right, so what happens when we have more than one base? What happens when we have more than one base? We're going to go through this one. If we have more than one base, just a second. If we have more than one base, it doesn't matter. Properties of exponents don't change. So if you have more than one base, the properties of exponents don't change. If you're multiplying the exact same base, you'll add the exponents. So looking at this example here, we have x squared y squared times x cubed y cubed. First thing you need to realize is that x squared y squared is not connected. That's just the same thing as x squared times y squared. And then we have x cubed y to the fifth. Well, that's not connected either. That's just the same thing as x to the third times y to the fifth. And now we know that we can reorder this in any order, so I'm going to put everything that's alike by each other. So I'm going to reorder it as x squared times x to the third times y squared times y to the fifth. I just reordered it, same exact thing, different order. And then we can go through and use properties of exponents to simplify this. When I multiply the same base, I'm going to add the exponents. So we have the same base of x's, x squared times x to the third, so we'll add the exponents, and 2 plus 3 is 5. Now we'll focus on y's. We have the exact same base, so we can add the exponents. So we'll have 2 plus 5, so we'll have y to the 7th. Now understand that would be your final answer. You can't combine those using properties of exponents. I'm going to sneeze. Okay, sorry, excuse me. You can't add those, you can't use properties of exponents to combine those. Those are not like bases, so that would be our final answer. Let's do another one. Negative 2x times 3x to the fourth y squared. Now once again, the negative 2 and x aren't connected, and the 3 is not connected to the x to the fourth, and it's not connected to y squared. So we can reorder this in any order. So we have 2 times 3. I'm putting my numbers by each other. I'm going to put my x's by each other. So I have x times x to the fourth. Now if you need to, as you go along, you can go through and cross them out so you don't leave anything off. So I like to do that sometimes. And then we have our y squared. Now piece by piece, let's go through and simplify it. Remember not to add the numbers, you just multiply those. What's negative 2 times 3? Negative 6. And then we have x times x to the fourth. We're not going to make the error that a lot of students make. We are going to put that 1 in there, and when you multiply the same base, you add the exponents, so that's going to be x to the 1 plus 4 is 5, and we have our y squared, but nothing to combine it with, and that's okay. So this would be our final answer for this one. All right, looking at this one, we have negative 4 times x to the 0 y times by negative 2x y cubed. This stuff's not connected, so we can reorder it in any order. So I have negative 4 times negative 2. Reorder those two things. I'm going to cross them out. And then I have x to the 0 times x. And then I have y times y cubed. And when you multiply the same base, you're going to add the exponents. All right, but these are numbers. We're just going to multiply our numbers. And negative 4 times negative 2 is positive 8. X to the 0 times x. Those are the same base, so we'll add the exponents, not forgetting that that exponent is 1. So we're going to have 0 plus 1, which is 1, so x to the first. And then looking at our y's, we're not going to forget there's a 1 there with our y, so we have 1 plus 3, which is 4, y to the fourth. Now we know that anything to the first power is just itself, so I'm going to write this correctly. X to the first power is just x, so I'm going to write it like this, and y to the fourth. Now let's say that we would have ended up with something like, let's say our answer would have been this instead. I'm going to change it and just say we simplified this and we got x to the 0 y cubed. All right, let's say that was our final answer, guys. We would not leave our answer like this. We would simplify it even further. We know any base to the 0 power is equal to 1, so that becomes a 1. Now don't add 8 and 1. This was multiplication. It was 8 times x to the 0, so it's still 8 times 1, which is just 8. So in something like that, you would have 8y cubed. So make sure in all your answers, if you ever had a 0 power, if you had anything left to the 0 power, go through and fix it. That's really 1. And then write the correct, most simplified answer. Okay, looking at this one, negative x cubed, a squared times 2x to the 5th, a to the 7th. Let's go ahead and simplify this one. It really throws people off. This throws people for a loop. They look in front here and they say, oh, well, that negative must go up with the 3. No, that wasn't negative 3 in the top. It was just out in front. And then a lot of people get really, they're like, what about that negative x? Well, you guys, there's really just like having a negative 1 out in front. Okay, they're not going to write negative 1. They're just going to write negative. So, but just treat it like a number, like negative 1. So now looking at this problem, now that we know that, we can reorder this in any order. So I'm going to write as negative 1 times 2. I just took care of my numbers. And then I'm going to write times x cubed times x to the 5th. And then I'm going to put my a's by each other, a squared times a to the 7th. And then I'm going to go through and simplify this piece by piece. Negative 1 times 2. Now once again, that was just a negative in front, but we know it's negative 1 in front then. But that becomes negative 2. And then we have x to the, when we multiply the same base, we add the exponents, so that's 8. And then moving on to our a's, when we multiply the same base, we add our exponents. So we have a to the 2 plus 7, which is 9. And that would be our final answer for that. All right, guys, now we're going to be dealing with negative exponents. So when you see a negative exponent, you might be saying, well, what about negative exponents? But properties of exponents never change. So no matter what, if you're multiplying the same base, you'll add the exponents. That's true, even if you have negative exponents, no matter what the exponent looks like. So even if we have fractions as exponents, we will still, if we're multiplying the same base, we'll still add the exponents, even if we have negatives. If we're multiplying the same base, we'll still add the exponents. So we're going to do this example. We have x squared, x to the negative 2 times x to the 3rd. In this one, we're multiplying the same base, so we know we can add the exponents. So negative 2 plus 3. Now we have to be really careful not to make any errors, because when we're adding negative numbers, students start to get really confused, and they're not careful, but we got to be really careful. So negative 2 plus 3 is positive 1. And then we know that x to the first is just x. So our final answer in this case was x. Let's do another one. So we have x to the negative 5th, y squared, times x to the 7th, y to the negative 1. Now once again, we're multiplying the same base, so we'll add the exponents, but I'm going to first reorder this. I'm going to write my x's by each other, so I have x to the negative 5th, times x to the 7th, times y to the 2nd. I'm reordering it in a different order, times y to the negative 1. And then piece by piece, I'll simplify it. So I'm going to focus on my x's. I'm multiplying the same base, so I'm going to add my exponents. And negative 5 plus 7 is positive 2. And then we have y squared times y to the negative 1. When we're multiplying the same base, we add our exponents. So that's going to be 2 plus negative 1. So we have y to the positive 1. Now, our final answer we're going to write as x squared y, because we know that y to the first power is just y. That would be our most simplified answer. Negative 2 times a to the negative 3 times 4a to the negative 7. We are familiar now, we're comfortable with the fact that we can reorder this and that the negative 2 is not connected to a to the negative 3 and that our 4 is not connected to a to the negative 7. So I'm going to put it in a different order. Negative 2 times 4 times a to the negative 3 times a to the negative 7. And then I'm going to simplify it. So with our numbers, we multiply that and we get negative 8. And then with this part right here, when we multiply the same base, we're going to add our exponents. So we have to be really careful. What's negative 3 plus negative 7? Once again, negative 3 plus negative 7. Now if I get that off to the side, just negative 3 plus negative 7. That's equal to negative 10. So we're going to have a to the negative 10. And that would be our final answer right there. All right, one more. Let's see, we have negative 3x to the negative 2 times y to the 0 times negative 4x cubed y to the 4th. Let's reorder this as negative 3 times negative 4, so that's times negative 4. I'm just reordering it, and then I have x to the negative 2, and then I have x to the third. I'm just crossing these out as I go. And then I have y to the 0, and I have a y to the 4th, and we're multiplying these things. And now we'll just simplify it piece by piece. Negative 3 times negative 4 is positive 12. And then we have x to the negative 2 times x to the 3rd. We're multiplying the same base, so we've got to add our exponents. So we have x to the negative 2 plus 3, which is positive 1. And then right here, focusing on my y's, when you multiply the same base, you add the exponents. So we have y to the 0 plus 4, which is just 4. And our final answer is going to be 12. X to the first is just x, so we'll write it like that, and then y to the 4th. That would be my final answer for that one. Okay. All right, so you're going to go ahead and actually finish up problems 11 through 16 on the worksheet. You'll do the whole front page of that worksheet, and you should be good.